So we have actually a trapezoid. The trapezoid being defined by two sides that are parallel, and only two sides. They want the perimeter of this trapezoid. So we clearly have to figure out whatever side x is.
Mm-hmm.
How are we going to do that?
I'm not sure.
Well, frequently with a lot of geometry problems, you have to draw lines, additional lines. In other words, if I drop a vertical right there, then this is a rectangle. And I know the distance from here to there has to be 250. So now let's examine this triangle over here. I also know that this height is 40 because it's a rectangle. And the only thing left to determine is this measurement right here. Let's call that A. Once we figure out A, that's the last thing to figure out. Now, let's talk about something that I'm not sure we've talked about before, and that's the Pythagorean Theorem.
A squared plus b squared equals c squared?
Yeah. In other words, whenever you have a right triangle, regardless of what those angles are, as long as that's a right triangle, then you can say that a squared plus b squared equals c squared. Well, we do have a right triangle here. We have a right triangle that looks like this. We know that's 50. We know that's 40. We know that that's a right angle. So, we can do the math and always figure out that this side is 30. Hold on. And the reason I know that that's 30 without really doing the math is because there is one particular right triangle that you want to really know. And that is one whose dimensions are 3, 4, and 5. That is your most basic, what they call a Pythagorean triangle. In other words, there's no 3, 4, 5, there's no 2, 3, 4, or 1, 2, 3, or 1, 2, 4. The smallest whole numbers that make up a perfect Pythagorean right triangle are 3, 4, 5, or multiples of 3, 4, 5. In other words, 30, 40, and 50 also work. So you want to learn to recognize these triangles, okay? Only because you're going to see about 1,000 of them in the next 3 years. So the moment I saw the 50 and the 40, I knew this had to be 30 without doing any arithmetic at all. However, just to be clear, 40 squared plus 30 squared is equal to 50 squared. If you do the math, you have 1600 plus 900 equals 2500. So all 3, 4, 5 triangles are right triangles. And any multiples of 3, 4, 5 triangles are similar. We talked about similarity before, and it's two triangles that have the same three angles. Well, these two triangles here are similar. Not only do they have the same three angles, but they have exactly the same proportion. The similarity ratio is 10 to 1 between this triangle and this triangle. Despite the way I've drawn it, it's 10 to 1. Okay?
All right.
All right. So, that means our missing side must be 30. That's 30. So yeah, you're right. The top side's 280. So we have 280 plus 50 plus 250 plus 40. What is that? 300, 580, 620. That answer there. Now, because right triangles are so important to figure out, let me give you a few. Let's do some drills on right triangles. What if this side was 5 and this side is 6? What is Z?
7.
No? In other words, we can always go back to the Pythagorean Theorem. Z squared equals the sum of the other two sides squared. So that would be like that. So Z is equal to the square root of that. And that's the way you want to memorize it. Any side of a right triangle is always going to start out square root of. Because if you're solving for the hypotenuse, which we are in this case, then Z is going to be the square root of 61. If we are solving for a short side, in other words, let's solve for this, and let's make this side 8. Well, I still have x squared plus 5 squared equals 8 squared. So x must always be, one of the short sides, is the square root of the hypotenuse squared minus the other short side squared. And those are the only two formulas you really have to memorize. I mean, you can memorize the Pythagorean Theorem and always work all the way back to that. But the fact is you're going to have to do this literally 500 times over the next 3 or 4 years. Literally. So you might as well figure out how to solve for the hypotenuse or how to solve for a short side. Notice that all answers end up square root of. So whenever you're solving a right triangle, your answer should be square root of. Let's make that 6. So what is x equal to?
The square root of 8 squared minus 6 squared.
You got it. What's x equal to?
Equals the square root of 17 squared minus 3 squared.
What is z equal to?
The square root of 3 squared plus 5 squared.
You got it. What you got right now, memorize. And don't lose it, because it's going to be a very valuable skill.
Okay.
Okay? And that skill being solving right triangles without having to go all the way back to the Pythagorean Theorem. Oddly enough, I was watching the British Open today, the golf tournament, and they mentioned the Pythagorean Theorem. I couldn't believe it. I mean, the green was here, and a guy had teed off from here, and he had hit his shot way over there. And so they were trying to figure out how far he was from the green. And they knew he was like 50 yards wide, and they knew that this was like 40 yards from the green. So they used the Pythagorean Theorem to figure out what this distance here was. That was pretty cool. But the Pythagorean Theorem is perhaps the most important theorem of all geometry. It really is. You can't do much geometry without starting with the Pythagorean Theorem. All right. We've got two squares. Got that square? And then if I take the midpoint of every side, I end up with that square. And the question is, what's the area of the square inside to the outside square? In other words, whatever this square area is, what is its ratio compared to this outside square? Well, how do we figure out the square or the area of a square?
Base times height.
Yeah, or one side squared, right? In other words, you're correct, base times height, but in this case, base and height are the same thing. So we're going to call this x, and this x. So we know the area of the outside square. Area of the big square equals x squared. Question is, what is the area of the inside square? Well, in order to figure that out, we have to figure out what one of these sides are. In other words, let's call that z. The area of the inside square is obviously z squared, but what is it in terms of x? In other words, let's solve one of these little triangles here to figure out what z is in terms of x. If I draw that little triangle, this little distance here is 1/2 x. This little distance here is 1/2 x. You see that? So what is this side right here?
Square root of 1/2 x squared plus 1/2 x squared.
What's 1/2 x squared plus 1/2 x squared? Hold on a second. I made a critical mistake here. I did not use parentheses. Whoops. It's the side squared. In other words, I have to square that and I have to square that, and I have to add them together, take the square root of it. That's what this is. Well, what's 1/2 x squared? What is that quantity equal to?
1/4 x squared.
Okay. So I can replace each of these with 1/4 x squared. So my answer is the square root of 1/4 x squared plus 1/4 x squared. How much is that? What is 1/4 plus 1/4?
1/2.
It's that right there.
Okay.
Okay? Which is the same as what you said. Now, what is the square root of that thing? Can I simplify it? Or do I need to simplify it? That's the answer for the length of GH. Well, so what is the area of this square?
You need to square it.
Okay, what do I get?
1/2.
I get,
Whatever.
in other words, whenever you square something that has a variable in it, you get whatever was on the inside. In other words, if I'm going to square that whole quantity, then I'm going to get whatever's on the inside, which is this. So, that is the area of the inside square. What was the area of the outside square? Because they want the ratio of the area of the inside square to the area of the outside square. What did I let this distance be?
Twice as much as
X.
or
So the area, the area of the outside square has to be x squared.
okay.
Notice, what is that ratio? What is that ratio?
1/2.
Uh-huh. And that's the answer. In other words, the x's go away. I introduced the x as a variable just because it made the problem easier to do. But there's no x in the answer. It's just this divided by this, which is 1/2. And notice that there was actually an easier way to solve this problem. If I take that quadrant right there, and I draw a diagonal, which is what line GH is, I know that this triangle is half of that square, correct? Whenever you take a rectangle and draw a diagonal, you get half the area. That's why triangles are 1/2 base times height, not base times height. Well, so I can do that with every one of these quadrants. I can divide that up into half. I can divide that one up into half. And I can divide that one up into half. So in each of these, that is 1/2 of that quadrant. That is 1/2 of that quadrant. So forth and so on. And I end up with an area that has to be 1/2.
Sorry, my
All right. Happens a lot for me. Usually it's my dog doing the barking. All right, another problem about squares. They want to know what the area of C is. Well, to know the area of C, I need to know one of its sides. They tell me the area of A, and they tell me the area of B.
I think if you square root the area of both A and B, you get the length of one of the sides of A and B, and
Which
you
are?
combine those two.
What's the square root of A and the square root of B?
3 and 4. So you would have one of the sides of C is 7. So the area of C would be 49.
Very good. All right. Let's see, this was intermediate. Let me go to another page. Still intermediate. Let's tackle some of these. Now, whenever you have a word problem in geometry, the best thing to do is to kind of draw a picture. Here's the picture they're talking about. 12 by 8. They want to put a frame around it that's exactly 2 inches thick. What's the area of the frame? And let me take that back. They want this area right here. They don't want the total area of the frame. They want this, just the frame itself.
So add 2 inches to the base and the height.
Okay.
So you get 14 and 10.
Hold on. You got to add 2 inches to top and bottom. In other words, this distance right here is 2 inches. Well, I got that same distance right there.
Oh, okay, okay. So 14 and 12?
16 and 12.
Oh, okay. Yeah, okay.
So that's the area of the outside rectangle. What's the area of the shaded area? How do I get the area of just what I have colored in here?
Subtract the area of the non-colored in.
You got it.
So subtract the area of the original rectangle from the area of the total.
You got it. And shaded region problems are always subtraction problems. I don't care how they word the problem. Sometimes they word it like this. There's a square, and there's a circle in the square, and they want to know what's all of this area here. Well, we don't know the geometry for calculating that kind of area. We don't have that math. If you gave me this area right there and said calculate it, I wouldn't have a clue how to do it. But what we do know how to do is take the area of the square, and we know the area of the circle. So if I take the area of the square minus the area of the circle, I'm going to have the area of the shaded region. And almost all shaded region problems, I've only seen one in my entire life that was not a subtraction problem. So, what's the area of the outside rectangle?
The outside, sorry, I can't see the dimensions.
16 by 12.
Oh, there it is. 16. 192.
Good. Area of the inside rectangle.
6. 192 minus 100, or 1. No, not 100. Well, where did I get that from?
8 times 12 is 96.
Yeah.
I was hearing you say it in the background, so I went ahead and wrote it. Okay? So,
190.
yeah, the area of the shaded rectangle is also 96, which is 192 minus 96.
Okay.
Interesting that you only have to increase the dimensions by 2 inches on both sides before you create an area that's twice as big. In other words, the outside rectangle ended up being twice as big as the inside rectangle. All right, let's see if we have time to do this one here. Yeah, we do. They say we have a quadrilateral. Well, that just means we have 4 sides. Nothing about them that we know. And we have side A, we have side B, we have side C, and we have side D. And they're telling us that the A, B, and C equal 2D. Well, can we figure out what D is?
Isn't it?
When you see a
Can you
problem
not
like
determine
this,
that?
always think about what kind of an equation can I write? First of all, what are the sum of the 4 angles? What is A plus B plus C plus D equal to?
What's B? 360?
360, you got it. Triangles are 180,
Okay.
quadrilaterals are 360, pentagons are 540. You gain 180 degrees for every additional side you get. Okay? So, if I can write this triangle, or this equation, excuse me, and they're telling me that A plus B plus C equals 2D, what's the next thing I should do algebraically? This is now an algebra problem, not a geometry problem.
I don't know. This one confuses me.
Well, there's my A plus B plus C. What can I replace that with? Based on this. A plus B plus C equals 2D. So I can replace that with 2D. Plus D
Oh.
equals 360.
So
3D equals 360. D equals 120. And that's the answer. In other words, most geometry problems always turn into algebra problems. So that's why you have to have Algebra 1 before you take geometry. Because you can't do geometry unless you know algebra.
Mm-hmm.
All right. Let's end there. Pick it up from there next time. All right, Cole. Have a good week.
Good. Thank you very much.
Bye-bye.